Hello and welcome to this Applied Ergonomics Lecture 20. So, we will be covering a new domain today, which is about biomechanics. It's a very important area in terms of ergonomics as well as treatment of injuries which happen because of heavy work or athletic work among various human subjects. So, let us look at this new area on biomechanics, which has increasingly gained a lot of prominence among the research community as of now. Has become one of the very fundamental areas of research contributions. So, what is biomechanics? So, if we really look at the definition which came up way back in 1974 from Has et al., it talks about biomechanics as the study of movement of living things using the science of mechanics. So, basically the way that a human being balances himself in all different positions, applies forces or throws projectiles at a certain velocity, they all are in a way related to the simultaneous movement of the musculoskeletal structure within a human body, and if we can organize the study of such structure, they can all lie into this domain of so called biomechanics. So, obviously the broader term that people would use is kinesiology, which is a term referring to the whole scholarly area of human movement study. Biomechanics is only the study of motion and its causes in living things, but this kinesiology is basically giving a broad domain of all kind of human movements which would exist. So, biomechanics provides key information on the most effective and safest movement patterns with reference to equipments which are being utilized, also while doing relevant exercises, and some of these exercises can improve, for example, human movement. Okay. So, how to even conduct motion in a particular guided manner is also within the domain of biomechanics. So, in a sense, kinesiology professionals solve human movement problems every day, and one of their most important tools is motion study, which is coming from this area of biomechanics. So, it becomes a subdomain of kinesiology. That is how we would like to explain biomechanics. So, the obvious question that one would ask here is that why to really study this whole new area of movement of limbs and other body parts, and if you really looked into what are the basic applications of such biomechanics related studies. So, one of course is to improve performance of work, performance in any sport or athletic motion, for example, or even performance and overall performance in movement, which is going to improve the quality of life in general of people. And the other broad application area is to prevent or treat injuries from happening. So, define work in a manner in a certain motion cycle, so that the body does not get affected too much, and again in case one has gotten affected, you could also help to treat by again incorporating small motions within different parts of the body for proper alignment of the musculoskeletal structure, which is the subject of attention here. So, obviously scientists from many different areas, kinesiology, for example, engineering, even physics, biology, zoology, these all different areas, they are interested in this area of biomechanics. The thing to be noted is that there are a team number of reasons why scholars from so many different academic backgrounds are interested, and one of the main reasons is that biomechanics is interesting due to the natural urge of human beings to marvel at the ability and beauty of movements. Okay, movements could be related to animals, movements related to any bio-inspired system. Okay, and then apply such movements as and when necessary to broadly improve one's day to day performance in terms of motions executed by the human body, okay, or in terms of prevention and treating injuries. So, let us look at the example problem of a gymnast and a coach, where biomechanics is such an important domain to solve the problem, so that a proper athletic motion can be executed by the gymnast. Let us say that there is a coach which works with the gymnast and whose goal is to have corrective actions for the problems related to the backhand spring of the particular gymnast subject. The coach observes several attempts and tries to judge whether the angle of takeoff, which is so backhand spring is basically as the gymnast kind of takes support of her hands and throws her body in a manner so that the body arches. So, first it goes at a certain angle and then it sort of rounds off and then it arches so that the gymnast can turn around in this manner through a backhand spring attempt. So, the coach observes several attempts and judges various things like what is the angle of takeoff, for example, of the particular gymnast, or maybe all the way from round off to the body arch, what are the body movements which are performed and which are the areas which need attention where performance is poor. So, the coach's experience tells him that this athlete is strong enough to perform a particular skill, okay, but the question is whether the decision needs to be taken for concentrating on the gymnast on the takeoff angle or more on the back hyperextension in the block. And so, basically either this angle needs to be changed so that more appropriate posture can come and the spring back can be performed adequately, or even while arching, if without focus on the angle of the initial takeoff, person arches more, still it can lead to a good posture, final posture because of the spring back. So, the coach in this case uses the knowledge of biomechanics to qualitatively sort of analyze the situation, solve the problem, and the coach from his experience knows that better arch affects the force of the gymnast, force that the gymnast creates against the mat, okay, and affects in turn the angle of takeoff of the gymnast. So, it decides to help the gymnast work on an arch rather than the angle of takeoff. So, even if the angle of takeoff is slightly loose because of the arching process, the gymnast can still conduct enough force so that the operation can be in place and the spring back can be successful. So, this is a sort of a case which says that how important would be biomechanics in terms of analyzing different sub motions from the overall process of the backhand spring backhand spring activity of a gymnast, and trying to work on that domain according to the build of the body or according to the build of the concerned person or the strength of the concerned person, so that overall the posturing at various stages, including the start of the spring back, the takeoff, the arching or the round off of the body, at all these different stages the postures are well maintained. So, that is how biomechanics is really very helpful in providing solutions, particularly athletic solutions in this particular case, as one can see in this particular case. So, there is a lot of redesigning that is needed for equipments, particularly equipments with which humans would like to perform activities. One of the finest examples is designing of this small handle racket for kids of a certain age group. They could perform better in terms of their ability to hit tennis balls if the racket handle is shortened. There is an organized study on this through this area of biomechanics, which indicates such a strategy, and so therefore, the sporting equipment design or redesign can be done according to age group to augment the performance. So, human performance obviously can be enhanced by improvements in design of various equipments, and many of these improvements are probably related to the overall weight. So new materials are in question if you wanted to make lightweight equipments. Even the engineering designs, like just I pointed out in case of this racket here, the lower size handle would give the concerned better impetus or better control of hitting let's say tennis balls. So when these changes are integrated with the information about the human performer, we can say that the improvements in equipments are based on biomechanics principles. Okay, so therefore what I'm referring here as this particular age domain or age group concerns a set of individuals with similar kind of strength, similar kind of arm movements or hand movements and also foot movements. And then there is also a requirement based on how fast a ball should be hit, how many times or what is the frequency at which the ball should be hit, and what is the kind of foot movement in between the two hits. So all these would try to in a very organized manner suggest the best possible equipment that can be used for improving the performance of the sport or any other activity. So there are many examples of how applying biomechanics in changing equipment designs has improved sports performances. For example, let's consider javelin throws. So in 1980s javelin designs were altered significantly. That's because you know, improved javelin designs in 80s resulted in longer throws, and that started endangering the other athletes who were around in the arena where such a throw would take place, or even the spectators sometimes. And so therefore a redesign was called for, a redesign was needed, so that even, you know, the new rules were set up actually, so that such sport doesn't become a health hazard or let's say an injury hazard to people who are within close distances. So biomechanics researchers also particularly Elliott in 1981 or Ward and Ruppel in 1980 were some of the first to call for smaller tennis rackets that more closely match the muscular strength of young players, based on which this tennis design came up. So you can see how improvement in performance in activities could take place through biomechanics. Some other models of performance improvements are listed here. For example, you know, body conditioning is a major aspect in today's fast changing world, and you know, body conditioning does happen through exercise and packed programs. People are generally interested to overall, you know, shape and size the body in a particular manner, so that the overall energy level goes up. And so biomechanical studies of exercise movements and training devices serve to determine the most effective training to improve performance. So in line with all this activity are computer controlled exercises, particularly testing machines, which actually are in business because they want to monitor at every instance how musculoskeletal performance changes between different activities, and how such movements would affect the body on a regular basis or vice versa. Such movements would affect the job at hand on a regular basis. So there has to be some computer controlled performance monitoring for and which comes out from the fundamentals of biomechanical principles to in a very organized way look at the way people do body conditioning and toning. So biomechanical research is a powerful ally in sports medicines, particularly in its quest to prevent injury or treat injury. It is important that such research is immediately utilized. There can be, because of fast movements, change in the limb structure which may result in dislocations, damages, muscle pulls, and so if there is an organized study about what impacts and what way, it can be utilized for quick treatment, so that the player or the athlete can be up and running in a few minutes and can join back the competition or the tournament. So also engineers and occupational therapists use biomechanics on a regular basis. This is important to design work tasks, also some assistive equipments. This is again a very important domain. Equipments make a huge amount of difference to life in terms of lessening the degree of human effort, and by giving, you know, passive leverage or some other assistance, and so therefore it's important that the knowledge of biomechanics is used to develop such assistive techniques, or even to design the overall work tasks in a proper manner, so that there are less injuries while delivering a task or a job, specific job. Biomechanics can also help to prevent physical therapists, help the physical therapist to prescribe rehabilitative exercises. Particularly important are these orthotics, which are support objects or braces, which would correct birth deformities. You already know about the dental treatment and how braces are used in dentistry, so that overall there is a certain way in which growth can take place, okay, and generally there is a correction of the overall shape of the human mouth based on such braces worn over a long amount of time. So you could actually do correct joint positioning. So of significant mention is this qualitative analysis of gait or the walking behavior of person. It's of a lot of importance, particularly in physical therapies. You can see a person here trying to climb up an elevation with a certain posture, and the posture being changed or validated through a therapist. So qualitative analysis of gait particularly is of a high importance in physical therapy, and treatment of many musculoskeletal conditions can generate because of just doing such qualitative analysis in a way a person walks, and the posture he takes in walking and climbing. So typically you could either do a qualitative or a quantitative analysis as regards this field of biomechanics. So when we talk about quantitative analysis, it's more about measurements, so it should involve measurements of biomechanical variables. Typically such measurements do need high speed computers, particularly for acquiring data, and also sometimes to do voluminous amount of numerical calculations. You could actually try to simulate muscular or musculoskeletal motion by using finite element analysis or other such techniques. So even short movements will have thousands of samples of data to be collected, scaled, numerically processed before any such tool is developed for predicting motions. So in contrast, qualitative analysis becomes sort of an introspective judgment, looking at some motions and trying to categorize those motions into ones which are good or ones which are inappropriate. So ideally we should use a combination of both quantitative as well as qualitative or judgmental analysis in order to study the whole area of motions related to limbs. And basically we can say that in both quantitative and qualitative contexts, identification of factors that affect human movement and performance is really what can be sort of observed, quantified, recorded, organized and interpreted at different levels of thinking. And so the idea is, with all this learning experience, tools can develop where they can have the capability of predicting based on quantitative as well as qualitative aspect any human movement, okay, and solve generally the problems related to such movements. So obviously this whole area is highly interdisciplinary in nature, because there is a part which is directly related to the human physiology, human body, and a part which is related to concepts of mechanics, and therefore it is really an integrated science, I would say, where multiple stakeholders are involved. Let us look at some example problems and try to see how biomechanics can be utilized. I would just like to mention about this stoop or squat positions for lifting of weight in a particular setup. It's a sort of a review for different lifting techniques which are around. By stoop or squat, I want to what I mean is basically these two different motions, okay. So this is known as a stoop lifting technique, Similarly, this is called a squat lifting technique. Okay. And if I looked at how the forces are applied to the musculoskeletal structure in both the cases, they are quite different, and quite different in a way that in some cases the forces are applied to more cross section of the musculoskeletal structure. In some cases it is applied to a very less section, and there is a possibility of more damage. So the objective of all this study is really about assessing the biomechanical evidence in support of advocating the squat lifting technique over the stoop lifting technique. And this can be a sort of a medical administrative technique to, or medical administrative practice to control either low back pain or even injury, back injury. So let us look at some tools for assessing both these techniques and try to understand. So I will basically partially cover this area today in the interest of time, and then maybe take this up for a future module again, probably which will be probably given to you next week. So here the idea is that if I looked at the force diagrams and how different cross sections of the human body or musculoskeletal structures are exposed, in case a person is lifting a 10 lb weight, you can see that the amount of impact which comes to particularly this portion of the human body, the musculoskeletal structure here, is significantly high, you know. So primarily because it's like cantilever orientation that we are talking about. The fixed end is really this pair of feet which is having a reaction motion, and then there is a this whole skeletal structure that is there is having almost a let us say a transfer of this force, so that it can hold back, okay, the weight of 10 kgs or 10 pounds. So on the other hand, if I looked at the other motion, that is the squat motion, you can see that a significant portion of the weight of the body, there is no, for example, cantilever orientation here. For example, you can see the overhang in this particular area, which is causing an additional force component to the skeletal system, whereas in this particular orientation you can see that a 10 lb is almost amounting to a 10 lb force on the musculoskeletal system, primarily because the weight of the human body is adjusted onto a broader base. There is very less chance of toppling, and so there is really no reverse torque which actually comes in this particular position, and it makes life easier for this human being in this position to lift a 10 lb or 10 pounds weight in comparison to the other one here in the stooping position. So from an intuitive level, from a qualitative level, certainly it appears to be better here, but you do have a very good quantitative measurement based analysis as well, which gives you most accurately the data which is going to conclude the same. And there are many facets which can get evolved in the process, which can advocate the squatting motion over the stooping motion for purpose of administrative control on let us say back pain or back injuries, so on and so forth. So if I look at loads and look at the musculoskeletal structure and how it gets oriented, so you can see the spinal structure of any subject, a human being, having ligaments, invertebral discs and vertebrae. There are also these musculotendinous structures comprising of muscles, musculotendinous junctions, tendinous insertions, and various types of forces are subjected to such structures. For example, this here right here shows a compressive force which has created a fracture. So you can see one of the damages created to one of these vertebrae here, which is because of a compression fracture. Similarly, there can be damages related to shear, to tensile stresses and muscular forces when it comes to different loads. So probably like to end this module here, but in the next module we will take up in a very organized manner by giving ratings to the different measurements which come for the different factors like compression, shear, tensile or muscular forces, based on which we can make conclusions about the right posture for picking up this load. So I like to end this lecture here. Thank you very much.